The future of warfare will not begin with a gunshot. It will begin with a signal sent between machines. And in recent years, that future has stepped onto public display floors in China, where autonomous combat robots, swarming drones, and AI-enabled battlefield systems are no longer theoretical. They are being built, they are being demonstrated, and they are redefining modern warfare. Every 2 years in the southern city of Zhuhai, something unusual happens. The world gathers, military delegations, defense analysts, journalists, and intelligence observers at one of Asia's largest defense exhibitions. What once centered around fighter jets and missile systems has evolved. At recent editions of the Zhuhai Airshow and military technology demonstrations tied to Army Day events, a different category of weaponry began to dominate the spotlight: autonomous systems, unmanned ground vehicles rolling silently across display floors, quadruped robotic platforms carrying sensor arrays, drone swarms moving in coordinated formations, portable robotic sentry systems scanning their surroundings. These weren't isolated prototypes, they were part of a coordinated narrative, a narrative aligned with a phrase that appears increasingly in Chinese military doctrine: intelligentized warfare. To understand what we are seeing, we must understand the evolution of modern warfare. 20th century warfare was mechanized: tanks, aircraft, artillery. Late 20th century warfare became informatized: networked systems, satellite guidance, digital command. Now, military theorists argue we are entering a third stage: intelligentized warfare. In Chinese strategic literature, intelligentization refers to integrating artificial intelligence deeply into military operations, not just for automation, but for cognition. AI-enabled target recognition, AI-supported decision acceleration, human-machine teaming, distributed swarm coordination. The objective is speed, not just firepower: speed of detection, speed of decision, speed of execution. In modern conflict, milliseconds matter. Autonomous systems compress reaction time, and that changes everything. At recent demonstrations, unmanned ground vehicles, or UGVs, have drawn particular attention. These platforms resemble compact armored units, some wheeled, some tracked, even quadrupedal. They are equipped with advanced sensor suites, thermal imaging cameras, remote weapon mounts, autonomous navigation software. Their role? Force multiplication. Instead of exposing human soldiers to high-risk environments, urban choke points, contested borders, fortified positions, robotic units can perform reconnaissance, perimeter patrol, and support operations. What makes modern UGVs different from earlier remote-controlled systems is AI integration. Computer vision systems can identify objects. Navigation modules allow semi-autonomous movement across complex terrain. Obstacle detection systems reduce dependency on constant operator input. Importantly, most displayed systems emphasize human oversight, but the degree of autonomy continues to expand. The strategic logic is clear: robots do not fatigue, robots do not hesitate, robots can operate continuously. In prolonged conflict, endurance becomes advantage. Another striking development: portable robotic sentries, compact turret-like systems capable of scanning wide perimeters, designed for border defense, base protection, and facility security. These systems integrate motion detection algorithms, facial and object recognition systems, thermal imaging, remote operator engagement capability. Such systems represent an evolution in perimeter security. Rather than relying solely on human guards, automated sentries provide constant monitoring. They also generate data, continuous environmental mapping, and threat detection. This data can feed into centralized command systems, enhancing battlefield awareness. It's not just about replacing soldiers, it's about building an intelligent sensor network, a battlefield nervous system. Perhaps the most transformative technology on display has been drone swarming. Individually, small drones are limited. Together, coordinated through distributed AI systems, they become exponentially more complex. Swarm demonstrations show synchronized formations, dynamic reconfiguration mid-flight, coordinated target tracking, autonomous obstacle avoidance. Swarm theory is based on redundancy and adaptability. If one unit fails, others compensate. If communication is disrupted, decentralized algorithms allow continued operation. This concept mirrors biological systems: flocks of birds, schools of fish, decentralized but cohesive. Military strategists see swarm technology as a force equalizer. Large numbers of lower-cost systems can challenge expensive traditional platforms. The battlefield becomes saturated, and saturation overwhelms defense systems designed for singular threats. Despite dramatic headlines about killer robots, the more realistic trajectory is human-machine teaming. In this framework, humans remain decision-makers. AI systems enhance awareness.
Robots execute repetitive or high-risk tasks. The integration model resembles Commander, AI decision support system, autonomous execution platform. This reduces cognitive load on human operators. In fast-moving combat environments, AI can process sensor data faster than humans. The goal is not to remove humans. The goal is to accelerate them. And in intelligentized warfare doctrine, speed equals dominance. One factor distinguishing China's approach is manufacturing capacity. Advanced robotics require semiconductors, sensors, precision engineering, battery systems, AI processors. China's industrial ecosystem enables rapid prototyping and scaling. Where other nations may test dozens of units, industrial capacity can potentially scale production. Scale changes strategic calculations. If autonomous systems can be produced in volume, deployment models shift. Warfare becomes not just high-tech, but mass-intelligent. China is not alone. The United States is heavily investing in autonomous systems. Israel has advanced loitering munitions and robotic platforms. Russia has experimented with unmanned ground vehicles. The difference lies in doctrinal framing. China explicitly integrates AI transformation into official military modernization timelines. By mid-century, the People's Liberation Army aims to become a world-class military force. AI is central to that ambition. This creates a new arms race, not nuclear, not purely conventional, but algorithmic. Nations compete in autonomous navigation, target recognition accuracy, swarm resilience, AI model training efficiency. The battlefield becomes computational. Autonomous combat systems raise profound ethical questions. How much autonomy is acceptable? What constitutes meaningful human control? Can algorithms distinguish combatants from civilians with sufficient reliability? International discussions at the United Nations have debated lethal autonomous weapons systems for years, yet consensus remains elusive. Some nations advocate strict bans, others argue for regulatory frameworks. Meanwhile, development continues. Technology often advances faster than policy, and autonomous systems sit at the intersection of innovation and risk. Beyond hardware, autonomous systems change military psychology. When machines perform frontline tasks, risk calculations evolve. Decision-makers may perceive reduced cost of engagement. Lower personnel risk can alter strategic thresholds. Additionally, public perception shifts. Robotic warfare may appear cleaner, more precise, but war remains destructive. That's it. If you like this breakdown, make sure to subscribe channel. Catch you in the next one.